Let me now introduce to you Sarah Parker. Sarah is Director of Education and Academic Affairs for the National Center for Human Factors in Healthcare and an assistant professor at the Georgetown University School of Medicine. And the title of her talk, which I love, is Your Unforgettable Introduction to How We Remember. Sarah?
So thank you for that inspiring start, kickoff to the day, and thank you, Ed, for getting things moving in such a So I got to kiss my husband on the kissing bridge right before we graduated, and then a year later, we came back to this bridge. He asked me, Sarah, do you want to go on a walk? This was an evening in December, and I said, oh, sure, whatever, not thinking much of it. I put on my Stay Puft Marshmallow Man parka, and we go outside, go for a walk around the university. I'm standing there, I'm freezing, and I keep putting my hands in my pocket, and I notice that Mike keeps trying to hold my hand. And I'm like, Mike, thank you very much. Like, I appreciate how kind you're being, but like, it's freezing. So I keep trying to put my hands in my pocket. Mike keeps trying to grab my hand. I can hear my echo. This is making me crazy. So I don't want him to hold my hand. We finally come to the bridge, and Mike reaches out to me. He reaches out to me, and I can feel his hand shaking through my parka. He puts his hands on my waist, and he says, Sarah, he asked me to marry him. I have this beautiful, very specific memory of this moment. It's such an intense moment for me. So I was talking to Mike about this yesterday, saying, hey, is it okay if I use the story of when we got engaged? And he's like, Sarah, I don't remember a single thing about that. Can you hit my next? So this is the foundational block of memory, right? We are who we are in large part of what we remember and forget. Memory, for the purposes of our day here today, memory is the process of retaining and reconstructing knowledge over time. Now you'll notice I didn't say memory is truth. Memory is the process of retaining and reconstructing knowledge over time. So from a basic kind of cognitive model, we kind of think of memory in this kind of linear process. So the first step of it is that sensory memory. So Ed talked about this a bit. This kind of, there's a lot of different stuff happening in your environment right now. You're kind of filtering it here and there. So the first is kind of a basic input. Next slide. So in order for these basic sensory inputs to get transferred into working memory, you have to attend to them. So there's a specific cognitive process that has to happen to move from sensory memory into working memory or short-term memory. It's kind of a flexible memory. Next. When you're sitting in working memory, how you kind of strengthen that relationship, you strengthen that memory is through rehearsal, right? So you go over it again and again and again. Next. In order for a working memory to make it into long-term memory, you have to encode it. Okay, so you kind of got these three buckets, right? We start with a sensory memory, then you move into kind of a working memory, and then eventually gets encoded into a long-term memory. Next. And if you want to call back that long-term memory, you've got to retrieve it. So it's all, and it comes back into working memory. So if you think about this information process, it kind of flows back and forth here. Next. At in this process, there's potential for decay, right? So in sensory memory, you kind of want decay, because you don't want to attend to everything. You want to attend to only the important things. So there's an initial kind of potential for decay there. In working in short-term memory, again, you're doing this kind of processing subconsciously. What's important? What do I know about this situation? Your frame comes into play here in your working memory. What you attend to, what you make go into long-term memory is also based on what you've learned previously. Next. And so, just a deeper dive into short-term memory. There's some wonderful research by psychologists Badley and Hitch who talk a lot about short-term memory. And the way that they frame it, I think, is really, really helpful. So the way that they frame it is that that short-term memory is a couple of different things. The first is it's like a sketch pad. They call it the visuospatial sketch pad. So right now, my visuospatial sketch pad is a bunch of your faces in tables. That's what I'm seeing. That's my snapshot of this moment. Okay? The other part of short-term memory is what Badley and Hitch call the phonological loop. So that's how you are listening. That's how you're keeping up with me until the end of my sentence. You remember the first bit, and then I'll fill in the next bit. This is why German is so hard for me. I don't know if any of you speak German, but the verb's at the stinking end. So you have to remember the whole sentence and then understand why you were listening. Short-term memory is this Dory phenomenon. So if we think about finding Nemo, right, 42 while do it. That is short-term memory. Okay? Next. Long-term memory can be split into a couple of different kind of models, I guess you could say. So there's this explicit declarative knowledge. I think in Ed's language, that would probably be closer to your conscious knowledge a little bit. So for example, within explicit or declarative knowledge, you've got facts and events. So facts, for example, Ken Jennings, do you remember the guy who won approximately like $1 bajillion on Jeopardy? He is a great example of long-term explicit semantic memory, right? He can pull those facts from anywhere. We've all got a memory of our first day of kindergarten. That's a long-term event memory. On the other side is the more implicit. So this is your more subconscious stuff you know, but you don't know how you know it, right? So classical conditioning is, I'm sure we're going to talk about Pavlov a number of times today. Procedural memory, you don't remember how to ride a bike, but it's there, it's in there, you can ride a bike. Priming, so your context really helps you know how to do your job. For example, starting an IV, you don't think about it step by step when you're an expert. Next. Next, please. So the way that we think about memory is often we think about it as if it's this. Are you guys okay hearing me? Okay, I really hate it because I can hear it flashing back to me. So memories, we think of memories as these long-term things that are often like recorded and played back to us, like a movie, for example. However, memories aren't that. They actually exist in your brain structurally. They exist in the form of synaptic connections between neurons, right? They're physiological events. That's what a memory is. It's basically a physiological event between different neurons in your brain. So our experiences, the things that we learn, and the things that we that create our memories shape these networks. So memories actually change the structure of our brain. Next. So this is. When we practiced yesterday, this is the part of my talk that I love the most, that is probably the most in the weeds. So I apologize, but I want to show you this because it is so cool how memory actually works in your brain. So you've got your basic neuron, right? And when your neuron gets excited, these little sparkles here are the gaps between the dendrites of different neurons. So if a neuron gets excited, it sends an electronic message down the dendrite, and it goes to the next neuron. And what happens is initially, when you first have an experience, it's kind of like a trickle, like a little creek, right? Just a little bit of chemical reaction from one neuron to the next. But as you repeat it, as you go through working memory, that creek becomes more like a flood, and then it becomes more like a cascade. And there are tons of chemical reactions that are happening between these neurons. That's what makes your memory. It's called long-term potentiation. It gets easier and easier for information to flow through these neurons. And it's not just a linear connection. It's this amazing network. Whoa. That's why I didn't want to use the mic. It's this network that goes across your entire brain, right? So next slide, please. So these memories don't just reside in one place within your brain. They reside across your entire brain structure. But what's interesting is that memories are so fundamental. They're so primal. They're part of our oldest parts of our brain, right? The hippocampus and the amygdala. Those are the basic structures in our reptilian brain. They are buried deep, deep in there. That is where your memories reside. They reside not just in the hippocampus, which is really the part of your brain that's most often associated with memory, but right next to it is the amygdala. That's your emotional center of your brain. So that's why these super strong emotional memories are so easily recalled, right? That neuronal connection between those two things is very close. It's very, very strong. Next. And so here's what I want you to do before you click on the video. Everybody, in envelope 1, there is, which is sitting on your table, there's a bunch of green half sheets. And go ahead and pull them out. There should be one for everybody at your table. So what we're going to do is we're going to watch this video, and then I want you to read your question on your sheet and answer it, okay? All right, so we're going to watch. You can go ahead and click on the video. Okay, go ahead and answer the question on your sheet. Okay, so this is part of an experiment that was done by Elizabeth Loftus and her colleagues. Elizabeth Loftus has done some amazing work on eyewitness memory. If you want to learn anything about that, she is an incredible researcher. Basically, what she found, this is just one video in a set of multiple videos that she gave to undergrads, and they ran from a series of between 5-second videos and 30 seconds long. And basically, what she and her colleagues did in this experiment was they asked people different leading questions. So on your sheet, for 50% of you, I asked, how fast did the car hit the other car? And the other 50% of you, I asked, how fast did the car smash the other car? And in Loftus research, what they found is completely predictable results, that if you use the word smash, the more violent word, people will predict the cars were going faster. So context matters. How I frame that question matters. One of the other really neat experiments that she and colleagues did was ask the question, how fast did the cars go through the yield sign? There wasn't a yield sign. But people are like, oh, a billion at minimum, you know? So what I want you to take away from this is that context matters. How the information is presented to you matters. How you think about it matters. Again, it goes back to that framing. But it's not just an interaction. It's part of how your neurons are set up to understand memory. It's how you think about memory, how you repeat them. Next slide, please. So another very strong emotional memory. I can remember very specifically where I was when I was told about the Twin Towers. I was walking between classes, and my friend Kate came up to me. And I think I went to class. I have no idea. Everybody has a specific memory associated with this. Go to the next one. This is called flashbulb memory. It's a really strong emotional memory. Because again, if you think back to the neuronal connections, that emotion that happens when you see something that's scary or really happy changes the way that your memories are encoded. This is a neat experiment that was done by Neisser and Harsh. They asked students between 1 and 2 days after the Challenger disaster, and then asked the same students again 2 to 3 years after the Challenger disaster what they were doing and what they remember. Next. And so here's a day or two after. I was in my religion class. Some people walked in and started talking about the explosion. I didn't know any details except that it exploded, and the school teacher students had been watching, which I thought was so sad. After class, I went to my room, watched the TV program talking about it, and got all the details from that. Next. So this is 2.5 years later. When I first heard the explosion, I was sitting in my freshroom dorm room with my roommate watching TV. This is the same person. It came as a news flash. We were both totally shocked. I went upstairs, talked to a friend, called my parents. Same person, same confidence that this is an accurate memory. Right? I mean, this happens. This is so I think back to my engagement story. I have no idea if that's the truth. Next slide. So for the rest of the day today, what I want you to remember are 3 things. First is that basic sensory input, short-term memory, long-term memory. Kind of that 3-step process that we go through cognitively. The second thing, you don't have to remember long-term potentiation. You can just call me. We can talk about it. What I want you to remember is that memory changes the actual structure of your brain, right? It changes your physiology. It changes your biology. And the third thing, and probably the most critical thing, is that memory is fallible and it's susceptible to influence. Next. Eric Kandel is one of the basic memory researchers. He won a Nobel in 2000 for his work on memory. He's one of the author of one of the recommended books in your packet. I was reading one of his papers in preparation for this talk, and this quote came up. It's a beautiful quote if you hit the next. What I want to pull out of it is this, that learning is acquiring new knowledge, and memory is that retaining and reconstructing that knowledge over time. And at the basic core of who we are who we are because what we have learned and what we remember and what we forget. And what I love of this is that you don't get that many Nobel scientists who use the word magical in their paper in Cell. I mean, but he says, and he and his co-authors say, learning and memory are 2 of the most magical capabilities of our mind. So for the rest of today, I hope that you can really enjoy yourself thinking about memory as a magical capacity that we have, that our patients have, that we have as an organization. And I hope that at the end of the day, we can take this away with us and apply it in our next jobs tomorrow. So thank you very much for your time. I really appreciate it this morning. Oh, sure.
Thank you, Sarah. That was absolutely outstanding. We have time for 1 or 2 questions if anybody would like to ask Sarah. Now, I am blinded by the light here, so I can't tell if anybody actually. Do we have any takers?
Yeah.
Okay, so let's get a microphone up here to the front.
I was curious about our earliest memories. Why, up to a certain age, it's blank as far as memory is concerned. Any comments in that area?
So, just as a caveat, we're reaching back into my very, very, very early memories of developmental psychology. So there are probably others in this room who could answer this question better than I could. But I think it's because your brain is developing at such a rate that those neuronal structures are not, they're not ready to take in that new and different information. There's so much like just actual living that has to be remembered that those memories about kind of what's happening in the universe aren't part of that, a part of your conscious yet. They might be part of your subconscious, like there are basic like life-saving kind of subconscious thoughts that most babies have, but they don't make it into that conscious level. And if anybody else in this room can answer that question better than me, please come and find me and this gentleman here.
We'll take one more question. Okay, we have two, one in the back over there and then one in the front. Michelle?
My question has to do with the role of pictures and video and watching that and how that influences memory, either loss of or changing what you remember by looking at a picture that you took a while ago.
So, like, for example, like a personal picture or like watching or videos?
Videos or your own personal pictures or your own personal videos, so your own memory.
Sure. So coming back to that kind of idea that memory is multimodal. So there's speech, but there's also kind of the visuospatial side of it as well. So not only are you recreating that memory by recreating that story, so those neuronal connections that were built through that story, but you're also getting a secondary input. So your network of neurons is actually stronger when you've got kind of this multimodal input to a particular memory. And the other thing is, when you've got video evidence, it's a little bit easier to remember what the truth of the situation was, right? So you can go back and look. So you're kind of getting a multi-pronged approach. They're a bit stronger. And again, other people may know that answer better than me.
So we'll take this one question back towards the door, and then we're going to...
Thank you. I just wondered if you might comment on the new research that's being done as part of the BRAIN Initiative on the importance of sleep to memory.
Sure. So, from what I know, is that speech is a huge time for reconsolidation of memory, right? So once you've gone from kind of, if you think about our three-step model, sensory to working to long-term, and then you want to retrieve it, when you're in long-term memory, after encoding, you're starting to consolidate memories. And so the whole idea is that sleep kind of helps your brain. It gives your brain that opportunity to really reconsolidate those memories, so bring those neuronal connections back together. I don't know the depth of the research on this. I just know at a very surface level that sleep is one of the critical kind of parts of having deep memory reconsolidation. It's kind of a neuronal thing at that point. So again, I'm sure that there are experts in this room